You would not.
Well, saying I'm not blind here. Let's try this. I'm not getting much signal up here.
That's pretty cool. Have you looked at the graphs? This says this is parts of the ozone per billion. Let's see. Oh, it's talking about Rocky Flats. That's pretty cool. That's over kind of by where Tommy lives, actually. In the Candelas area. One more time.
You know what am I saying?
Can I?
No. What am I feeling?
Do I know about atmospheres? Yes. Take your time, babe. I just don't have the best hearing either planet, so. Of course. Oh, baby.
What now? Close memory, close speed, just going to close. How about this? Close.
What does it remind you of? Smoke on the water? You're right. I mean, it does remind me of smoke too. It smells better than smoke. I don't like the smell of like campfire smoke. Gives me asthma. This ash reminds me of the sand dunes down in the San Luis Valley. Go there. Super fun. It's definitely going to be on a hot day. That's what I've heard. But once a year, the river runs through it. And that's the best.
Well, and that's when. So what I think I've heard people say is like around Memorial Day is when you should go. So I'm always like, oh, okay, well, I'll wait till then. But then you never get to really go. Plus you have to.
Guys, this is nothing. When I press this, play, it's nothing.
My mom grew up out there, so we have family that's like 5 miles away. So we're out there.
It's something.
But what's hard about it is like what's actually only attraction down there is, I mean, they have like the alligator park.
The place that the alligator park and the.
Oh, the UFOs.
Yes.
Yes. We do have those, but I can see why people don't quite get around to that one just because it's dry. Is it? It's dry. It's such a great road. For like an hour and a half. So, I know. I love it.
There's a hot springs down there that I want to go to called it's called and it's like on the other side of the mountain, I guess, from Sand Dunes. So it's like on the other side of the mountain. So I guess it's like a really long drive just to go around the mountain.
Yeah.
But like some of the hot springs they have, I guess you can like look out in the valley, so that's why they call it Valley View, and there's all the different temperatures, and they have you can go camping there. It's a dark sky place,
Oh, fun.
so you can do telescopes. Yeah, it seems really cool. So I was like, I want to stay there, do the hot or the dunes, and then
That's smart. My graduation trip, we did the Mount Princeton hot springs. That one's a nice one, but I've been to better. Like, Augusta Springs is probably a little nicer than Mount Princeton.
is it
But, like, living areas, like, the cabins are super small.
okay?
So, if you're going to, like, chill,
I've driven by Mount Princeton, so it's check out St. Elmo's.
fine. Yeah, that one's a super, I love it. Love it.
And I went to Montrose.
Okay, yeah. fireworks?
Fire.
Oh, a fire tornado. Yeah. You are correct about that.
Or when lightning.
Or when lightning hits it. You are very
Let's
correct.
try this one, guys. This one is press. Where's the winner?
I'm glad you're out of your booth though.
This.
Look at this big piece of hail ash. What if that hit your car? I think it put a big dent in the car. Maybe like that big. Hail really messes up the car. Little dings, huh? Until it's a big piece, then it makes a big ding. Or knock you out. That very well could happen, huh? Because it's ice. Ice is like a rock.
Hey, teacher, go bathroom.
Yeah, go for it. Do you know where it's at?
Yes. And now make a tornado, guys.
This is talking about microbursts. I think we had a microburst a couple years ago. It's called color. It does look like an arrow. Where's the wings? It's a good question. You can't get too far without the wings, huh?
What's this? Yep. This is another way, guys.
It's almost lightning. It's almost lightning.
That's interesting, like a little section.
Of FM
Yeah.
in force.
It's talking about
It's like dead center of all of it too. You know?
Yeah.
Not just of Africa, but of like the world map. That's kind of crazy. I'm gonna take a picture of that for my son.
It is please.
Yeah.
You should try it, guys. You should try it. make a thunderstorm, or make a tornado, or make a hurricane, or videos from this. You should try when you come to visit to the museum.
Tommy, we're gonna watch the video. You'll come hang out with us. Help us pick what we're gonna see. What? Do you wanna go watch the video with us, Mr. Andrew?
Yeah?
Yeah.
For the YouTube.
Sweet. You can take video of it. All right, friends. Let's choose the video.
But let's not do this. Ugh. I'm gonna see the video, guys. Go pick the video.
I'm just gonna go take a peek on Savannah and make sure she's doing all right.
Okay.
There we go.
Enjoy your video.
Gang.
Be right back.
Gang.
Tornadoes or twisters are columns of dangerously fast rotating air formed from storm clouds. When the narrow end of the funnel touches ground, it becomes a tornado. This part of the funnel can be almost 2 miles wide. The most dangerous tornadoes have 200-mile-per-hour winds that can pick up and carry a house. Most are much smaller, but still dangerous. The majority of the world's tornadoes occur in the United States in an area called Tornado Alley. Tornado alerts are broadcast over radio, TV, smartphones, and with sirens. If a tornado approaches, shelter in a basement or interior room away from windows and doors.
This is
Oh.
short.
Do we need to pick another one? Okay, what next? Do we want? There's space weather.
Yeah.
You want space weather?
Yeah.
Okay. Do space weather. Maybe. Okay.
When people think of natural disasters, they tend to think of earthquakes, tornadoes, or hurricanes. But Sarah Gibson, national physicist at the National Center for Atmospheric Research and funded by the National Science Foundation, is more concerned about a phenomenon called space weather that begins millions of miles from Earth and could mean lights out for the entire world. On October 28, 2003, power unexpectedly went out in parts of Europe. Satellite communications were interrupted, forcing the rerouting of air traffic. And astronauts on board the International Space Station were ordered to seek shelter in a protective door.
The effects of a big solar storm expected to be felt on Earth today.
What caused all of these disturbances? Surprisingly, these disruptions, known as the Halloween storm of 2003, were the result of a storm taking place on the surface of the sun, part of a complex set of natural processes known as space weather.
Space weather is how the environment around the Earth
all the solar system in the area because of activity of the sun.
The most recognizable form of space weather is the aurora borealis, the northern lights. While the aurora is a harmless and dazzling light show, it is the result of a potentially dangerous solar weather event called a coronal mass ejection, or CME.
CME is when you have a sudden explosion of mass from the sun that is hurled out into the solar system. And it travels a million miles an hour and gets to this Earth in anywhere from 1 to 4 days.
CMEs originate in the area that surrounds our sun called the corona. These solar storms begin as sunspots, areas packed with massive amounts of energy. Occasionally, the energy continues to build until it snaps, spewing large amounts of X-rays and other particles into the outer edge of the Earth's atmosphere.
And it's not they're strong with a strong magnetic field has a lot of energy. And this energy can drive one of these coronal mass ejections.
The radiation that is released from a CME could be deadly. Fortunately, Earth has its own protective magnetic field that shields us from most of the harmful effects of space weather. But if a CME is strong enough and on a collision course with Earth, it can impact electronics and technology in the sky and on the ground, just like it did in 2003.
The Halloween storm of 2003, that was a spooky one. There were several storms all lined up. And these CMEs were notable because there were so many of them and they were so big.
Halloween storm of 2003 stands as a dire warning of what could happen if a bigger or more numerous set of coronal mass ejections were to head directly for Earth. A CME takes at least 24 hours to reach Earth. Not a lot of lead time. But further study into the sun's magnetic field could help forecast these storms and better predict their behavior.
First thing we see that flash of light. And then we radio it. It's different from outer space. The next thing particles that were accelerated to almost like rushing into the sun.
As the particles reach Earth's magnetic field, they will cause complex interactions and increase energy within the Earth's atmosphere that can wreak havoc with power grids, satellites, and interfere with GPS, setting off a chain reaction that could disable communication systems worldwide.
Communications, navigation, GPS, pretty much everything that we've come to depend on will go on the fritz.
Landline and cellular phones would stop working, credit and debit cards wouldn't be able to process, the internet could go completely dark, no email, social media, or search engine. In the worst case scenario, even power grids would be dark.
All told, they could be serious problems that could have impact for months or even years.
To better prepare for the next major CME, scientists around the world are monitoring the sun's activity and gathering valuable information about the behavior of its magnetic fields. Using this data, Gibson and her team at NCAR's Mesa Lab have constructed mathematical models that accurately simulate the effects of space weather on the Earth. Further understanding of the basic functions of the sun, Gibson believes, is crucial to improving predictions and for aiding engineers, power companies, and governments in what could be the worst natural disaster.
I think the most important thing we can do right now as scientists is to try to understand the magnetic field inside the CME as it comes from and figuring out other ways to get those observations to change our predictions as we go.
Predictions that can mean the difference between a very bright and a very dark future.
Over.
Do we want to do one more video before
Yeah.
we go upstairs?
Yeah.
You're downstairs.
We are downstairs, huh? You guys gotta help me pick it. Want me to put this in your backpack?
Me,
Yeah, it's kind of warm in here.
yeah.
Which one do we want to do? Do you want to do space weather?
That's what we just did.
We just did that one. Sweet. Do you want to do supercomputers and modeling?
Yes.
I know a lot of our friends like computers in here.
Here's a question. What can we learn using a supercomputer like the one in our supercomputing center? Take Dr. Tornado. She loves tornadoes. She wants to know everything about them. What makes them form? What determines determines their strength and size. Why do some last long while others don't? Dr. Tornado doesn't have the resources to build a big tornado making machine. And where would she safely test it if she did? She needs a way to make a tornado without making a mess. So Dr. Tornado gathers all of her friends, scientists and students alike, and they go on a hunt for data. Their goal is to collect information like temperatures, precipitation, wind speeds, barometric pressure, and radar data, and put them all into our supercomputer along with the laws of physics, equations that govern the Earth system. To do this, Dr. Tornado's team follows potential tornado-producing storms to make observations, send out weather balloons, and place tons of stick nets, many weather-recording tripods all around the area. And Dr. Tornado? She drives a huge truck with a radar on the back as close to a tornado as she can, without getting hurt, of course. Remember, Dr. Tornado is a trained scientist, so don't you go trying this. Once all of the different bits of data are collected, they are entered into our supercomputer and added to a model of the atmosphere. Because there is so much data and the equations are so complex, you need a supercomputer to calculate the outcome. Now here comes the fun part. Dr. Tornado is able to change the settings of the model to see what effects it would have on the outcome. What would happen if it were a few degrees cooler? What if there was less water vapor? What if the storm was moving faster? Each slight change has an enormous impact on the outcome. This way, Dr. Tornado can better understand how a tornado works, and in turn, we can make better warning systems that will save lives. But that's not all. Other scientists who have built models similar to how Dr. Tornado built hers can remotely log in to use this supercomputing power. Models that can predict the path of a hurricane, that can predict solar flares, and that can help us better understand the Earth's climate. In this way, we can answer all sorts of questions. Like, how much water and energy will we have available to us in the future? What will our agriculture look like? How high will the sea rise? How will climate change affect extreme weather events? And how will solar storms affect us here on Earth? These are just a few of the ways we can benefit from the Supercomputing Center. Think about what questions you would want answered.
Nice. All right, guys, we're gonna head up. Are we done with downstairs?
Yeah.
Are we ready to head upstairs and check it out?
Yeah.
Sweet, and there's a little bit of coloring we can do. Do you want to carry? Are you good carrying that? You took that from me. Do you want it? Okay, if you don't want to carry it, I'm more than happy to help. All right, friends. How about we all just go up in the elevator together?
Okay.